Hi everyone, welcome back to the AI language. In our last videos, we have already seen how to set up our development environment on a MacBook. We have seen how to install a simulator and run our first app across iPhone, Android simulators, Mac OS, and Chrome Web. And we have also seen in the third video a basic overview of our workspace. All the Visual Studio Code, the project structure in Flutter, and the main files over there, and also installing the extensions for Dart and Flutter. So today we are finally going to look at what powers Flutter, right? So Flutter is Google's software development kit. It's a UI toolkit, so it helps you make wonderful UIs, right? But it is written in some language, and that programming language is called Dart. Now, the best way to learn this is to go to the official Dart documentation page, and we can go through some of the details over there. So always keep this base for Dart documentation handy, somewhere in your bookmarks, and you can always visit this page whenever you want. And the best way to understand the basics of Dart that we need for Flutter app development is go through this language tour over here. And I'm going to go through this in a bit more detail compared to what they've mentioned over here, so that we completely understand how does Dart work, and we can use that effectively when making our Flutter apps. At the same time, there's a handy tool which is called Dartpad. So you can always search for it online, and through the Google link, or if the website name is dartpad.dev, you can open this particular tool, and this particular tool helps you write Dart code and run it, so that you can do some basic checks as and when you'd like to do that. So you can write some Dart code over here, click on run, and see the output over here. So if you're stuck in some problem and you want to just try out some different combinations of code to see how that works, you can actually try it out over here, right? So let's go to the Dart basics and start with the first example that they have given over here in the walkthrough, which is the main function. So the main function is an entry point for every Dart program, and also for Flutter apps, because they're written in Dart. So the entry point is the main function, and we saw that last time in VS Code. Let me see if I have that open. Yeah, so here we have it, and if you see, this is the entry point for your Dart program in which is the Flutter app that we had run last time, and this is where your code starts executing. The void over here means that this particular function, the main function, does not return anything. So there's a operating system or a running environment that calls this function to start your app or your program, but it doesn't expect anything to be returned by the program. It just wants the program to run, right? So that's why it's void, which means nothing to be returned from the function, and that's why you don't see a return statement, which is typically used to return values from a function, right? Then you have these parentheses, which basically is the list of should contain the list of arguments that this function takes, and over here we see that this does not take any arguments, and a very similar thing is seen in our Flutter app as well, that there are no arguments being taken over here as well, right? The curly braces basically denote the body of the function. So over here it's just a simple print hello world. So hello world is a very basic typical program used in all programming languages to just showcase the first simplest program that anybody can write in any programming language. Okay, so let me copy this code from here, and we'll go to Dartpad, and we'll replace the code over here. Okay, and we'll click on run. So we give it a few seconds, and there we have it. So it's a hello world that is printed out. So this print statement is basically used to print out text on the console, right? So text and other values, right? So if you have your Flutter app and you have a print statement over here, you would see that output in the console over here when you run your Flutter app. So you can run your Flutter app, and whatever is printed, you will see it getting printed out over here. And the way to do that is just write print, and in single or double quotes you enter your text value, and you end every statement with a semicolon over here. So that's basically your main function, which is the entry point for your app and for any other Dart program. Then we go to variables. So Dart is a type safe programming language, which means that it will explicitly specify types for each variable, or figure them out using some kind of inference, where it actually uses the initial values, to understand what are the variable types. So over here you see that the keyword var is used to declare a variable called name. Name is actually the name of the variable over here. Similarly, you have year as the name of this variable. And then you have an assignment operation which assigns a string value to this particular name or a text value. So strings are basically used to store text values in Dart. 1977, this is an integer value. So year will be inferred as an int type, int. Name will be inferred as a string type. Antenna diameter will be inferred as a double type or a float type, because it's saying it's 3.7 over here. So this has a floating point number over here, so it will be a double value. Then you have a list object over here. So this will be inferred as a list object, and it will be a list of string types. So you'll have Jupiter, Saturn, Uranus, and Neptune. So these are all the planets, and so this flyby objects is basically a list of all the planet names, which are string objects. So you have a list of strings. Then you have image. So image is basically a map. It's a key value pair, a map of key value pairs. The keys over here are both strings, and the values over here are actually not consistent. So one of them is a string and one of them is a list of a single, it just has a single element right now of a string. So it's a map of string to a dynamic object, right? So it's a map of string to object. So a very important suggestion is to always give your variables an explicit type. That is, you specify whether you want it to be a string or an integer or a double or a list of strings and so on, so that this helps in code readability. Whenever you're looking through a large piece of code and the language would infer the variable, but for you to infer it after having spent a lot of time elsewhere, coming back to an old code will be difficult. So it helps you in code readability, and it's just a good practice to specify your variable type, right? So let's just copy this list of variables and take it to the Dartpad and try to print out the types, right? So just remember, always have the main function in Dartpad and just put your code in between that. That's a requirement of the Dartpad, right? And if you click run over here, it's simply going to run and assign the variable the values, right? So what we can do is we can add a print statement, and we can put the variable name dot runtime type. This is going to tell us what is the runtime type that Dart has actually inferred, and we can do it for all the variables. Let me just put this print statement everywhere and then change the variable names. So we have year over here, we'll change this. We have antenna diameter over here, we'll change this over here. And then we have flyby objects, change this. And then we have image, and we'll change this. And then we just simply click run over here, and we get all these variable types that Dart is inferred. So you see that name is inferred as a string, integer for the variable year, and antenna diameter is inferred as double. The next one is a list of string, which is the flyby objects, and then image is a map of string and object, right? And just to show this, so if I made this consistent, the type consistent, so both are now strings. Both the key value pairs are string to string mappings, right? And if I click run, now Dart should infer this as a map of string to string. All right. So that's all about variables in Dart, right? Okay, so now let's look at control flow statements. So control flow statements are basically used to evaluate conditions in your code, and based on that take some actions, or to actually repeatedly run a part of the code. So if you have used some other programming languages before, you would recognize conditionals and loops as the typical control flow statements, and Dart offers all of them to you. So this is a very basic conditional, which is the if statement. An if statement typically evaluates a condition to be either true or false. So you'll say, if this variable value is expected to be an integer is greater than or equal to 2001, so it evaluates true or true. And if this is true, the first block of code is done, which is going to print 21st century. If it is false, it goes to the else if. So else if is the statement which will actually provide now a second condition to be checked, which is if the year is greater than or equal to 1901. If this is true, this condition, this print statement would be run, and it would print 20th century on the console. And lastly, you could have an else, just a plain else statement, which would run a code block if none of these conditions, the if and the else if, are true. Then you have a for loop. So a for loop is basically used to run a certain piece of code for a specific number of times. Generally, there are two ways in which you could specify a for loop. So this is a slightly enhanced version of a for loop, where you run the for loop for the number of times you find a particular object in a list of objects called flyby objects, right? So we had checked that flyby objects is a list of planet names. So for every planet name, which is denoted by object over here, it would run print object, the code print object, which is going to print the planet name in this, right? So typically over here you would give a list or a collection of items which are iterable. So you would iterate over this list, and for every item in the iterable or the collection or the list which is denoted by object, you can take an action on that particular item inside the code block. Then the typical for loop, which you would see at other places like even in C++, is where you actually initialize a counter. So over here the counter is month, or you initialize it with the value 1, and then you repeat this for a known number of times. Like you would say that, okay, let's repeat it from 1 to 12, so month is equal to 1 and goes till 12, and then you increment the counter after each run of the code block. So it's a month plus plus, which is going to make the month go up by 1 every time the code is run. And then you would print month. So this would basically print month like 1, 2, 3, 4 till 12 on the console. Then there is the while loop. So while loop is used to actually run a particular code block till a specific condition is true. So you could give the year a value. So for example, the year has been given an initial value of 1977. So you could run the while loop while the year is less than 2016, and you would typically increment or update this value inside the code block so that you can recheck it every time the loop is run. This is basically going to print every year starting from if there was a print statement over here. There's no print statement right now, but the year would basically go from 1977 to 2016. So we can actually take this code and just copy it from here and paste it over here and see what this does, right? So we have pasted it over here, and let's just indent it a bit to make it more readable, right? And let's go ahead and run this code. All right, so we can see that for the year case, it's going to print 20th century, right? Because the year is 1977. So there we have it. Then for the objects in the flyby objects, it just prints each planet name. So Jupiter, Saturn, Uranus, Neptune, just goes over each of the object and prints that. For the month case, it prints each month from 1 to 12. And for the year case, it doesn't print anything. But if we added a print statement over here, you would expect it to print all the years starting from 1977, 1978 actually, because we have added the print statement after the increment of the year. So to begin with, the year would be 1977. The first statement would increment it to 1978, and then the first print would happen. So you have it from 1978 all the way to 2016. When your year is 2015, it's still going to be less than 2016. So it's going to enter this code block. It's going to increment it by 1, which is 2016. And then it's going to print that year. And the next time it checks for this condition, your year is going to be 2016, which is equal to 2016 and not less than. So it's going to evaluate to a false, and it's not going to continue further. So that is all about the control flow statements, the conditionals and the loops. Okay, so now let's look at functions in Dart. Functions are basically a way to encapsulate your code and give them a name called the function name, right? So that you can call that function anywhere inside your code rather than having to repeat your all the lines inside the function definition of the code block, right? Over here we see an example of a function. The name of the function is Fibonacci, which is represented over here, and then there are these two parentheses in which you have a list of arguments. Over here it's just one single argument represented by a type integer and the name of the argument, which is n over here. You can have more arguments separated by a comma in front of this. There's also a type mentioned over here which basically denotes the type of the the value that is returned by the function. So over here it tells us that Fibonacci returns an integer value. If you were to call this function with a particular value of n, in response or in return you expect a value of type integer, and that's computed based on the logic given inside the function body. So the function body is enclosed inside these curly braces. Now for this particular function, the function body has a simple conditional, which is an if condition. It has these two vertical pipes which denotes the or condition, the logical or, and it checks for two of these conditions. So it checks if n is equal to 0 or n is equal to 1. So this is the equality operator. So it is going to check if the double equal to checks if n is the same as or equal to 1 or not, whereas the single equal to is the assignment operator, right? So it checks for both these conditions. If any one of them is true, it will return the value of n directly. Otherwise, it's going to return a value which is computed by calling the function again. So this is called recursion, when one function calls itself again on a modified value of its argument or on whatever value of its argument. It's basically a recursive function call. So it's going to call the same function on n minus 1 and also on n minus 2, add the two results together and return that. When the function is called n minus 1, the same logic will be repeated and it might further call the same function again and again. Now it basically over here you're defining the function. So this is the function definition. Over here you're calling the function. So you're calling the function with a value of n equal to 20, storing the result in a variable whose name is result and the type is not specified. So Dart will basically infer the type. Okay, so let's just copy this particular function and paste it over here in Dartpad. Let's just indent it for better readability and let's run this once. So and actually we need to print the result over here, and we can comment out the earlier prints from before so that we can actually have a concise output to check. Just for your information, that command and / is the way you add comments. Select a line and press command / and it adds this double comment which is used to denote a single line comment. And now you can actually run this and you see that the print statement gives us 6765, which is the 20th Fibonacci number in the series, right? There's another shorthand notation that Dart provides us for functions with a single statement, right? So you basically over there you use with the function name, you put the argument list, and instead of having curly braces with the code block and return statement, you just put a fat arrow or a arrow syntax as this is called and put the expression that you wish to return. And this particular syntax is used over here in this where method. So I'm just going to copy this statement and we're going to paste it over here to understand this better, right? So if you look at flyby objects, this was a list of strings and the where method acts on that list. It takes in or iterates on each element of the list, which is a string value over here represented by name, and it tries to filter out those particular values which match a certain condition. To represent that condition, we pass in a function over here. This is a special notation for a function, and this is a special function which is called a anonymous function because the function doesn't have any name. It just has an argument which is called name over here, which is the name of the planet inside this flyby objects list. And then the condition that we're checking for is whether the planet name contains turn or not. As we see, one of the planets, which is Saturn, contains and passes that filter criteria. So this is essentially going to just return a new list with just one value, which is Saturn, with one element, Saturn. That's a list of string with just one element, which is Saturn. Now for that list, we again apply a method called for each. So as the method name suggests, it might be suggesting to you, it is going to iterate on each of the elements in that list. In this case, it's just one element, Saturn, and then take that element and pass it to the function specified over here, which is the print function. So this is just going to print Saturn on the screen, and we can run this and check this out for ourselves. And here you go, there is Saturn on the screen. Just to make this a little bit more clear, what we can do is we can actually put the proper code block instead of the shorthand notation. So if we were to do that, we would add the curly braces to represent the body of the function. Now this function has to return something. Earlier we skipped the return variable and the semicolon because we were using the shorthand notation, but now we need to add this. And now we can click on run again to see that this has the same effect of returning Saturn over here. So essentially this entire thing is a function, and this just shows us that this function has no name, it's an anonymous function, and it is being passed as an argument to another function, which is the where method for flyby objects. Similarly, print is a Dart function which is being passed as an argument to the for each function. The where and the for each functions are acting on the lists preceding this dot, and basically iterating on each of the elements. The where function is filtering out the elements for us. The for each function is basically passing each element to the function specified over here. So that's how functions work in Dart, and it's pretty versatile in the sense that you can actually pass functions as arguments, you can assign them to variables, and we'll see this as we go along programming in Dart and making Flutter apps. Okay, so let's go back to the Dart documentation, and next we have comments and imports. All right, so this is pretty straightforward. Comments are used inside the code to actually explain what you're trying to do in a particular code block or file, or for documentation, right? And as far as explaining the code is concerned, it's generally recommended that variable names, function names, etc. should be chosen as in a way, and the code should be written in a way that the logic that is being used in the code follows from the code itself rather than having to explain it. But in case you wanted to add these comments, double slash before a line is how you add a single line comment. Triple slash is used to add documentation related comments, where you're actually writing a document around how the function works, right? And if you would want to have multi-line comments, this is how you do it. You put a forward slash followed by an asterisk, and then you put the comment over multiple lines if you want, and then you can end this by putting a star and a forward slash again. And then we come to imports. So imports are used to import APIs defined in other libraries. APIs are basically application programming interfaces. So these are like functionalities that are provided to you by other libraries. So as an example, you could want to use math functions inside your programs. For example, if you wanted to find the cube of a function, cube of a number, you could ideally write a function yourself, multiplying the number by itself 3 times to get the cube, or you could just use a library to square the number, to find the square root of a number, and so on. So all those kind of functions, math functions, would probably be defined in a library like the math library in Dart. If you want to use that, you can import external packages, right, using import package. That basically is those are all the packages that are the non-core libraries, and you would import them like this. You could also import other files by simply writing import and the path to that particular file. Import statements are generally included at the top of your code file in each of the files as needed in each of these files, and this is how you basically import all these different libraries. All right, so let's look at Dart classes, and there's an example over here of a class with 3 properties, 2 constructors, and a method. So let's look at this, right? So let's just go through it, line by line. So class, this is the keyword which is used to define the class, and this is the name of the class, which is spacecraft. So this defines a class called spacecraft over here, and with the curly braces, basically you enter into the body of the class, right? The class has 2 properties called name of type string, which is probably going to hold the name of the spacecraft, and there's a launch date of type date time question mark, right? So this question mark basically says that this variable launch date can either contain an object of type date time, or it can contain the value null, right? So this means that launch date is a variable of type date time that is nullable, so it can hold a null value as well. It's going to have a launch date if the spacecraft has been launched, and it can be null if the spacecraft hasn't been launched, right? Then there's a getter over here. This is called a getter, which is basically defined by using the keyword get. The getter returns a value of type int, which is nullable, so it can hold a null value, and it basically, the name of the getter is launch year. So this basically tries to provide you a way of getting the launch year using an object of the class by calling this particular getter, right? And what this does is that basically returns, and this is a shorthand notation that we had seen earlier. This basically checks the launch date variable checks whether the question mark again over here says that it checks whether the launch date is null or not. If it is not null, it will get the value of the year, right? There's a property year from the launch date from that object. And in case it is null, it's going to return a value null into launch year, and that value is going to be returned to the calling code block. So, and since this can be null or it can have an integer value representing the year, the return type for this is int with a question mark. So it's a nullable integer, right, value. Then we have a constructor. So a constructor basically helps you construct an object for the class or an instance for the class. And in this case, this is the main constructor, right? With syntactic sugar, which basically means that it's shorthand. It's defined in a shorthand notation. Generally, constructor is not generally, but constructor is actually a function. So for a function, you would need to provide arguments with a type and a name of the argument, right? But in this case, you can see that's not done. A shorthand has been used, and that's why it's mentioned as syntactic sugar. And this just means that whatever are the two values provided over here, those should directly be assigned to the name and the launch date property over here. So that's the syntactic sugar over here, right? Okay, so next we have a named constructor. So Dart allows you to have multiple constructors. So this is like an additional way you can construct an instance of the class, and this has to be given a name which you actually specify like this. So over here we are trying to provide a named constructor, which is to actually create an instance for a spacecraft that hasn't been launched, right? And why would we do that? Because for a spacecraft that hasn't been launched, you would assume that you just need the name. There's no launch date. So instead of creating a spacecraft object with both the name and the launch date, you would just call the named constructor and you would just specify the name, and that would help you create an object. So this might seem trivial right now, but when you're actually dealing with objects with multiple properties, with classes with multiple properties, this is actually pretty handy to create instances of that class in different ways, providing only part of the property values and then assuming defaults for the other. So over here what this does is this named constructor uses this colon over here, which basically passes on its arguments to the main constructor, which is represented by this, and this means that whatever is the name that you provide this, it's going to pass on to the main constructor, use that name for the name variable, and a default value of null for the launch date, right? And that is how this named constructor will create an instance, and this instance is going to be returned to the calling code block. So now let's look at the method for this particular class. So there's a describe method, and this is a way for the class instances to actually perform actions, right? So the describe method is probably a way over here that the spacecraft can describe itself, and it has no arguments and a void return type. So it's basically using the properties of the class itself, like the name, the launch date, to describe the spacecraft. So this is a simple print statement with spacecraft and the name of the spacecraft. The dollar sign over here is actually used to resolve the actual value being stored inside the variable name rather than actually printing dollar name on the console. Then we get a launch date into a variable called a local variable called launch date. So this is the property of the class, whereas this is a variable local to this method body. Over here, the Dart compiler or the Dart runtime can actually check what the value is for launch date. If it's null, it can actually store it in a datetime object which is nullable. If it is not null, it can actually store it in a datetime object called just datetime, right? Not without the question mark, right? So that check and that's called type promotion, where Dart can actually store the variable in a type that is more restrictive, or that is uh, more like what the variable is at runtime rather than providing a broader variable type. Now, if the launch date is not equal to null, then this particular method will take the datetime class and call the now method, which returns the current date time, and then it's going to calculate. It's going to call the action called difference on that particular value of date time and calculate the difference of the date time currently to the launch date. Then it's going to call a method in days, which is going to give you that value in the number of days. So it'll be an integer basically. And then the tilde slash defines an integer division. So let's say you get like 900 days. So you'll divide 900 by 365 and just discard the decimal portion of it, and then assign that value to years, which is the name of the variable of type int. And then it's going to print the same thing. So it says launched, and then it's going to print the launch year, and then it's going to say these many years ago, right? And this particular launch year is going to come from this particular getter. Otherwise, if the launch date is equal to null, it's going to print unlaunched. And this is how this method works for this particular class. And this is how you would actually use this particular class. So to define a spacecraft, to define a new instance of a spacecraft, you would say spacecraft and then pass a name for this spacecraft and pass the launch date if it has been launched. Otherwise, you could actually define it without the launch date, and for that you would use the named constructor, which is unlaunched.